Then the last aspect of this project that I wanted to show had to do with the coupling and the parasitics. So here you found, let's just assume, that we had 100% passing on our design goals. And we then wanted to move out of this ideal schematic environment where we're using wires and grounds to connect everything. And we're going to move to our PCB board, where we come in and laid out the actual matching network. So in this case, we have our GPS port over here on the right-hand side connected to ground. We've got our Wi-Fi port across the bottom, and then we have all of the other inductors and capacitors comprising the matching network laid out here. And so now that we have this full 3D structure, we have the copper traces, we have vias, we have pads, we have antenna coupling onto here. And so this is going to require us to come up with new component values, because the old component values from the ideal schematic are not going to work here due to that coupling and matching network parasitics. And so in order to analyze this, we come into our simulations window. In this case, there's a response matrix simulation that we'll create. As I can see that there are 10 ports over here in my circuit component list. And so this response matrix is essentially going to create a port, 10 by matrix that has all of the matching network parasitics accounted for and captured. So once I have that response matrix, I can come into my schematic layout, and this might take a minute for you to adjust to this new type of layout or way of thinking about it. But I have my 10 port response matrix simulation here, and then on each one of those ports I have the capacitor value or inductor value or the voltage source applied here. So it's essentially it doesn't look like the layout that we saw in the previous example where you have your, the layout like you had over here, right? It doesn't look like this, but we've taken the 3D structure, put it into here, and so now we're just interacting with the individual components. So whenever we change the inductance value or the capacitance value, we're considering the matching network parasitics and all of the full wave effects in our results. And so the same idea of having design goals, allowable component values, looking at S parameter isolation or system efficiency results, having tuning sliders, and optimization, all of those features are still available in this type of setup. It just so happens in this case we're analyzing this full geometry whenever we're deciding on our component values. So the Diplex match example, we introduced operating modes, optimization, and the coupling and parasitics.